Hello, welcome back to my YouTube channel. It's Dr. Jeremiah here again, and today I'll be showing you how to solve calculation questions under friction, including the dreaded friction on an inclined plane. So let's just get started with the video. Make sure you watch to the end so you don't miss out on important steps. I'll be using to solve them. I'll be dropping some shortcuts. I'll be dropping the formulas. I'll be explaining the concept. Usually, why students fail questions under friction on inclined plane? They don't understand the concept of how it works. So today I'll be showing you the concept and everything about friction. So let's get started with the video. So the first thing you need to know about friction is that friction opposes motion. It opposes motion. That's the first thing you need to know. That, for instance, if I'm moving in the x direction, or let's say I'm moving in this direction, friction will be backward. So frictional force, the motion is the body is moving towards you, while the frictional force is along my direction. So that's what friction just means. It's not a big deal. Now let's just get started with it, because today is for calculation and not for explanation. So just go learn some basic stuff about friction. So what do you need to know about friction? The first thing, we're going to be starting with friction on an horizontal surface. Friction on an horizontal surface. Now, take for instance, just follow me. Make sure you have gotten your notes with you. So, take for instance, we have a mass. Let's use a block of mass, 10 kg. So this is a block of mass 10 kg on an horizontal surface. So this is the horizontal surface. I told you we're going to start with friction on an horizontal surface before we go to friction on an inclined surface. Now, this is the block. This is the block of mass. Now, for instance, if I pull this block, just follow me. If I pull this block along this horizontal surface, I will call this P. That's pulling force. I'm showing you why students find this thing problematic. It's not a difficult thing. Now, this pulling force. I told you that friction opposes motion. So if the body is moving in this direction, I pull it, for instance, Dr. Jeremiah pulls this 10 kg block in this direction, it surely means that the block is moving here. Now, if it is moving in this direction, where will your force be? You already know from my definition that your frictional force will be in this direction. So I'm going to label frictional force as FR. So this is frictional force. I hope you are following. So we have been able to resolve two forces now. We have the pulling force, which is to pull the block, and the frictional force opposing the pulling force. This is very important when you are solving questions, so please take note of it. Now, another important thing to take note of is that this block his weight is acting downwards. I know from physics that your weight equals to mg. So you already have 10 times 10. Don't use it as 10, usually 9.8. So 10, just approximate it as 10. You have 100 newtons. Now, tension. These forces in the horizontal and forces in the vertical. So the forces in the vertical is weight and tension. Tension opposes weight. Tension, or we call it reaction force, opposes weight. So let's better call it reaction force here. We have reaction. So reaction is opposite weight. For a body moving in an horizontal surface, reaction force is opposite weight. And usually, you can say reaction equals to weight. So reaction equals to mg. For an horizontal surface. So these are the resolved forces on an horizontal surface. Hope you are getting it. So this is the first thing to know about resolution of forces on an horizontal surface. Now, what you need to take note of next is the net force. Now, if you look at this frictional force and pulling force, there's a net force, because if I drag this body along this surface, this frictional force is moving in this direction. So what is the net force? The net force just tells us that let me use this guy. The net force just tells us that net force, let's call it F net equals to what direction is this body moving? Is it moving in this direction or this direction, or is it static? So if I pull this body along this direction and it moves, so I'm going to get P minus FR. This is the formula I'm going to be using to calculate for net force anytime, any day. P minus FR. That's pulling force minus frictional force. Because if I pull this body along this surface, it's going to move in this direction. So pulling force is surely greater than frictional force. But please take note, there are two kinds of friction. We have the static friction and the kinetic friction or dynamic friction. And for the dynamic friction or kinetic friction, pulling force is surely greater than frictional force. Yes, except the body is coming to rest. So pulling force is greater than frictional force. So I'm going to have, maybe for instance, pulling force there is 10 and frictional force is 7. That's why the body can move. You get? But for static friction, please take note that the body is not moving. The body is just about to move. You look at the definition very well from the textbook. I told you guys to go check it out. So that it's going to say that when the body is about to move, you have static friction and not kinetic friction. Please take note. It's a very popular Jamb question. So when the body is about to move, this pulling force is trying to overcome the frictional force. It's trying to overcome the frictional force. And take for instance, we have 10 Newton as pulling force, trying to overcome 10 Newton also frictional force. So this for static friction, the net force is 0. For static friction, the net force is 0. Please take note, for static friction, the net force is 0 because the body is not yet moving. It's just about to move. So static friction is the force that must be overcome before a body can begin to move. So the net force is 0 Newton for static friction. Please take note. Now, another thing you need to take note about net force is that F net force, equals to mass times acceleration. Please take note. Many students find this confusing because sometimes they'll give you net force, or they'll not give you net force, rather they'll give you mass. They'll say look for frictional force, and they gave you pulling force. What do? You look for net force, then you use this formula and look for your pulling force or frictional force, as the case may be. Sometimes there's a question that I asked. I can't remember the year. You asked the question. He just gave you mass and acceleration, and look for net force, and they gave you pulling force. They gave you weight and reaction. They didn't give frictional force, something like that. I mean, you just start crying, yo. What are you supposed to do? Just times mass and acceleration. These kind of Jamb questions nowadays, we're just asking plain question, but you don't know the simple question. So please take note that net force equals to pulling force and frictional force, and also equals to mass times acceleration. So we have two formulas for calculating net force. What we get? Now let me tell you some things about frictional force, because it's going to be very important as we progress. One of the laws of friction states that let me use this guy. One of the laws of friction states that frictional force is directly proportional to normal reaction. It's directly proportional to reaction. Now, this means that so this FR, I just write a small letter R. Hope you are following. So this means that FR is directly proportional to reaction. Now, if I introduce my constant, now we produce constant in mathematics. So if I introduce my constant, this is directly proportional. So I'm going to have KR. But in physics, I don't just use K. The constant is specific. So this constant that you have here, U, not actually U, is mu. Yeah, but people in Nigeria pronounce it as U. So mu, or whatsoever you want to pronounce it as, just know that this is the symbol. So this symbol is known as the coefficient of friction. I hope you are getting what I'm saying. So this is the coefficient of friction. This guy, let me write it here in case you didn't see it. So it's known as the coefficient of friction. So you see, they want you to look for coefficient of friction. This is just the formula to use. F equals to coefficient of friction times reaction. That's just all you need to know. Then another simple relation that you need to take note of is that if I make coefficient of friction, let's use this place. So you make sure you're going to have U equals to FR. That's this frictional force. Please just try to differentiate it. Just know it, you get. So frictional force over reaction, normal reaction. Now, also this guy equals to tan theta. When I solve question on incline plane, something very strange thing. They don't need to derive anything. Just know that every time coefficient of friction equals to tan theta, you are good to go. If you are in the hall, they say look for theta. Just do theta equals to tan inverse of coefficient of friction. You should know all these trigonometry calculations. So we get. So that's just all you need to know about friction. We're going to get into solving questions right away.
Breaking news: are you looking for the right place to prepare for the 2026 Jamb exam? The Unusual Science Tutorial is the best place for you. My name is Mohammed Temitayo, a newly admitted nursing student of the prestigious University of Ibadan. As an ex-student of the Unusual Science Tutorial, I will testify the Unusual Science Tutorial classes are exceptional, and even their free classes are what you get in most paid tutorial classes.
Alright, so let's move. The first question should be shown on your screen now. I will read from here. It should show on your screen. Just read from your screen and follow me. It says a block of wood of mass 5 kg is pulled on a platform by a force of 40 Newton as illustrated in the diagram. Let me put into the diagram. So there's no need to go into the diagram. We can represent it by ourselves. So the question says, read the question. It says a block of wood of mass 5 kg. Write your 5 kg here, is pulled on a platform by a force of 40 Newton. So it means the pulling force P equals to 40 Newtons. Remember our representation earlier. If the frictional force experienced by the block is 12 Newton, you know that frictional force acts to this direction. You're going to have Fr equals to 12 Newtons. You see, if the frictional force is 12 Newton, calculate the magnitude of the acceleration of the block. I'll say something like this. You know, say, why am I calculating acceleration? Also, some people don't know that net force, that formula of net force I gave to you guys earlier. So, now that, what's the simple thing to do now? Your net force equals to pulling force minus frictional force. And your net force equals to mass times acceleration, which equals to pulling force minus frictional force. Now, what is pulling force? 40 Newtons, and what is frictional force? 12 Newtons. So you have mass times acceleration. You can see put the net force down to be very fast. 40 minus 12, we are going to get 28 Newtons. Now mass times acceleration, we divide both sides. What are we looking for again? Acceleration. So we divide both sides by mass. We're going to get acceleration equals to 28 divided. What is the mass? Class 5 Newtons. Hope you followed. So 28 divided by 5 will give you what? Just quickly punch that. 28 divided by 5 will give you 5.6 Newtons. That should be option B. Option B on your screen. So hope you get the concept. Very simple stuff. Just simple. Just know how to draw the diagram. Okay, pulling force to direction, frictional force is to the direction. Then net force equals to pulling force minus frictional force. Then net force equals to mass acceleration, as you all know. You can decide to just look for net force first. Then now say F equals to MA and do your division. But those are waste of time. This is a Jamb, writing a Jamb exam that is timed. You don't have the whole time, so you have to answer it very fast. So push UTME, every exam you're going to write in your life is timed. So know how to solve questions very fast. So let's quickly move to the next question. Question 2 says a load is pulled at a uniform speed along a horizontal floor at 45 degrees to the floor. Okay, let's quickly represent the diagram now. It says a load. remember that we must represent the diagram. A load is pulled at a uniform speed along a horizontal surface by a rope at 45 degrees to the floor. So this is the rope, pulling this guy. So it's this is the rope. I probably put this question to show you something. So this is the rope. Now this is the horizontal. Normally this is where the pulling force should be, So he said that the rope is 45 degrees to the floor. So this is the floor. This is the horizontal. So it's 45 degrees. So this is the rope. So what's the next thing? We're going to resolve it. If the force on the rope is 1,500 Newton, so the force on this rope, like this, is 1,500 Newton. The force. What is the frictional force on the load? What is the frictional force on the load? That's the frictional force in this direction. What's the frictional force? Remember our horizontal surface, and this is the load. Now, this question is just simple. I was telling you guys about static friction. So let me start from there. I was telling you guys about static friction, that frictional force equals to pulling force in static friction. And this tells you that the question said at a uniform speed. You read the question again. It says at a uniform speed. Just take note that whenever you see uniform speed anywhere, that acceleration is 0, and also static friction. So that's static friction. Remember I told you earlier that for static friction there is no net movement. So it means acceleration is 0. That's what we mean by uniform speed or uniform velocity. So acceleration is 0. That goes to tell you that net force or F net, anyone wants to write it, equals to pulling force minus frictional force, which gives you 0. So if you have pulling force minus frictional force equals to 0, this means that pulling force equals to frictional force. To bring frictional force to the other side. What we get? So when we have static friction, pulling force equals to frictional force. Please take note. Now, with this being said, how do we now solve this question over here? Now, I was telling you guys that what to get here now is our frictional force, because it's static friction, because there's acceleration equals to 0, uniform speed, uniform velocity, and all that. Whenever you see body about to move, uniform speed, just know that it's static friction. So now, how do we resolve this guy? Please take note that your forces on an horizontal surface must always be to the horizontal. So we're going to resolve the force of this rope to the horizontal. We're going to be getting X value here now, X Newton. So we're going to be resolving this force to the horizontal direction. And how do you resolve forces to the horizontal direction? Remember your resolution of vectors, component vectors. That forces to the horizontal are going to do, so let's say let's say P, that our value pulling force, equals to R cos theta. Why to the vertical, you have P equals to R sin theta. Now let me quickly just tell you a simple trick. I've removed that diagram. So imagine this was weight. Sorry, this is weight is downward. Imagine this reaction. And the reaction was put like this, inclined to this guy. You must resolve it to the vertical. You must resolve the weight to the vertical. Imagine it's inclined to this horizontal. You must resolve it. So weight and reaction must be resolved to the vertical. But pulling force and frictional force must be resolved to the horizontal. So it cannot be like this. You get? So say it's pulled at 45 degrees. Just resolve it to the horizontal. And to resolve the horizontal, we use P equals to R cos theta. Now if you do that, you're going to get what's the value again? 1,500 Newton times cos 45 degree. So that gives you 1,500 times, what's the value of cos 45 degree in trig ratio? They have 1/√2. Now if you do 1/√2, just press on your calculator. Let's go. 1/√2. Just punch it. So that gives you 1,500 times 1/√2. I think 1 over root 2 should be 0 point something, 0.7 something. So that gives you 1 0, yeah. So our answer is, we write it now, answer equals to 1060.6 newtons. I think that should be option D. Option D. So you have gotten our answer 1061 newton. So that's the value for the pulling force. And remember that pulling force equals to frictional force in static friction. So the value of the frictional force is 1061 newton. So I'll be giving you an assignment at the end of this video. So watch to that point to test yourself. Alright, so let's quickly just go to friction on an inclined plane. Now, the first thing you need to take note of is the diagram. Please follow carefully, because many students ask me, I find it difficult to understand how it works and all that. So it's from this diagram I'll be drawing now, this explanation, I'll give you a breakdown that I'm going to use to solve any question. We're going to solve some questions, but this is very important. Okay, let's take for instance, this is an inclined plane. This is an inclined plane, and we have a block of mass, let's say 10 kg. Then remember I told you under evolution of forces for horizontal surface that we have a force acting from here. Yeah, a force. It's called the normal reaction. You can call it the normal force. So we have normal reaction acting upwards, and also from this block we have a weight acting downwards like this. We have a weight acting from this point. Okay, let's draw it from this point. So we have a weight acting downwards like this. So this is called weight. So these are the first two things you need to know about when you're resolving forces in the vertical: reaction and weight. Weight acts downward, reaction acts upward. Now what's the next thing we need to know now? This inclined plane has an angle. That's why it's called an inclined plane, because it's inclined at an angle. Now see, from here, this is what most students find confusing. Now this weight, we're not going to use to solve questions, because if we see, if you make this thing a straight line, let's try to give some broken lines. We are going to have an angle here. We're going to have an angle here. Remember I said during our friction on an horizontal surface that when you have an angle, when you have something inclined at an angle, you don't use it. You cannot just use weight like this. Now you have to resolve it either to the vertical or to the horizontal. So let's label here as X and here as Y. Now this is the resolution of weight. Let me quickly say this. We have the resolution of weight along the plane and down to the vertical, perpendicular to the plane. So this is along the plane. So what we're going to get here is along the plane because it's horizontal. While what we are going to be getting here now, it's down the plane. It's one corresponding to reaction here. You get? Because we have to resolve it. Now, what are we going to do next now? Remember from your angles, you have what we call from trig ratio. So we have now, if you want to resolve this guy, this is opposite, this is adjacent, and this is hypotenuse. Now when the angle is facing is known as opposite from trig ratio. Now opposite over hypotenuse, this is where weight is. Opposite over hypotenuse, we're going to have opposite over hypotenuse is what? Sine. This is cos and this is tan. So we have opposite over hypotenuse. This is the hypotenuse, this is the straight line. So this is the hypotenuse. So opposite over hypotenuse, so we're going to have sine here, sine theta, W sine theta along this plane. How is it sine theta? Now we have, I told you opposite over hypotenuse. So we have sine theta equals, just follow me, sine theta equals to x opposite over hypotenuse. What's the hypotenuse? The weight. Now if you cross multiply, you make this over 1, you're going to get x equals to W sine theta. So you see, this is W sine theta. Now for this place, we do same thing. Cos theta, we have this adjacent. So we have cos theta, just follow me, equals to y over, what do you have here? Weight. Weight is this place. Yeah, this is weight. So I'm going to have y equals to w cos theta. So it means this place we have w cos theta. What does this tell you? That along the plane or down the plane we have w sin theta. Hope you are following. While across this plane, that's the magnitude of the weight balancing the reaction force, it's w cos theta. That brings us to this important derivation. So now that we know that we have w cos theta here and w sin theta here, what do we do next? So the resolution of the forces in the vertical is what? R equals to w cos theta. So we're going to label it as equation 1. Yeah. So w cos theta, that's equation 1. That's the forces acting in the vertical, perpendicular to the plane. So this guy is called perpendicular to the plane. Why? This w cos theta is called perpendicular to the plane because you see, this is perpendicular to the inclined plane. So it's perpendicular to the inclined plane. Now we say along the plane and perpendicular to the plane. What is the resolution of weight? Please know this basic thing. In my own Jamb, they didn't ask me to even solve calculations. They just told me along the plane what's the resolution of weight. So please take note. I think I said this in one of my videos. Yeah, on the important topics to take note of in physics. Go and watch that video. I'll place it in the description. Yeah, I said that question word for word. It was my Jamb question. So let's continue. So we have w sin theta. Now along the plane, what do we have? So along the plane we have w sin theta already. Now if this block is at rest and maybe sliding downwards. So let me just even say this: the proposed motion for a body on an inclined plane is downwards. Why? It's imagine that the block should slide downwards. With the way the block is placed, with the way the inclined plane is structured, the block will slide downwards. So the proposed motion is downwards, except otherwise stated. Yeah, we'll solve some questions. Now, so if the proposed motion is downwards, what does that tell you? It tells you that frictional force is upwards. I said this at the beginning of this video. Please go back. That friction opposes relative motion. So frictional force is upward. So what does that tell you? That the resolution of forces along this plane is going to be net force, let's call it F net, equals to where is the motion going? Where is the body going? The body is going downwards. So I'm going to have w sin theta minus frictional force. So that we can call this equation 2. And if the body is at rest, if this body is at rest now, we can say net force is 0. I explained this in the previous video. In the previous solving on horizontal surface. So we are going to have w sin theta equals to frictional force. Now if the body is at rest, So this is equation 1 and equation 2. Now, let's just call this equation 3. So remember that frictional force equals to mu half. That's coefficient of friction times reaction. And this is frictional force. So this is coefficient of friction. Now, there's something we can do here. Because when we use it for your solving. Remember that R equals to W cos theta. So we can replace here. We can replace R here now with W cos theta. You save your time in the hall. You can call this equation 4. You see, I've given you simple derivation which means to solve any question on inclined plane. And also lastly, note that I think I said this, net force in the previous video equals to mass and acceleration. So they say, in case they say find the acceleration of the body, all you just need to do is A equals to, for instance now, I'm find acceleration of the body here. What will I do? MA, let's go here, MA equals to W sine theta. Hope you are following, just follow, equals to FR. So I'm going to have A equals to W sine theta minus FR divided by mass. So very simple. So that's just the way this inclined plane works. With this, we are going to solve questions now. Just so that this is perpendicular to the plane and this is parallel to the plane. That's along the plane, perpendicular to the plane. So I think with this we are good to go. Now let's solve the first question for today. Now the first question is showing on your screen. It says a block of mass 50 kg slides down a plane inclined at an angle of 30 degrees to the horizontal. If the coefficient of friction is 0.4, calculate the frictional force between the two surfaces. Now, we already know our formulas as let's first write the parameters. I think there's a video I did on how to become a god in physics. I told you that when you're solving questions, always start with the parameters. So please go and watch that video so that you understand how we solve questions in physics. So the first thing, now we have mass equals to 50 kg and the angle of the inclined plane is 30 degrees. Then it says if the coefficient of friction is 0.4, calculate the frictional force. Coefficient of friction mu equals to 0.4. Then we have G equals to 10 meter per second square. Now the body say the question says the block slides down the plane. So draw the diagram. We're going to have, let's just draw a simple diagram. We're going to have I hope you can see it clearly. So we have slides down. So the body is moving downwards. So it means normally we have our W sine theta here. Since the body is sliding downwards, it means frictional force is acting upwards. Simple thing, it opposes motion. Now since it slides down, the reason I drew the diagram is that it's so we know that it's sliding downwards or upwards. If it's sliding upwards, frictional force is acting here, and this guy is still here. This guy is always here. W sine theta is always here, and W cos theta is always here. Yeah. So since this guy is acting downwards, it means we have net force that's along the plane. We have F net equals to W sine theta minus frictional force. Then what are we looking for? We're looking for frictional force. Okay. And now that the resolution perpendicular to the plane is R equals to W cos theta. We have already done this. And also they now say look for frictional force. We're looking for frictional force. Let's write it out. Frictional force. Now, if you look at this very well, we don't know what is net force because we're not giving acceleration in this question. Please take note. Acceleration is not equal to G here. Please take note. It's not equal to G. So we don't know acceleration. So it means we can't use this guy to calculate frictional force. Now, but we know W cos theta. And remember our fourth derivation earlier that frictional force equals to mu R. Yeah. So we have mu W cos theta. The second question I'll be solving very fast. I just want to see buttress on the point. Now, frictional force equals to mu W cos theta. What is mu here? Now we have 0.4. So we're going to do 0.4 times what is mass? 50 times 10 times cos theta. Remember that to convert mass to weight, we multiply by 10. Now quickly punch this on your calculator. We have 0.4, do that, times 50, okay, times 10 and times cos 30. Cos 30 is supposed to be 3/2. Now but let's just use, okay, since our answer in question is in decimal point, so let's just leave it in decimal form. We're going to have 173.21 Newton, and that is option B. So you see how simple this question is. You just need, I've just escaped all this point, all these formulas. I'll just come here straight. That's why it's important for you to know the derivation, how to derive it. but in case I forgot in the exam hall, I will derive it from scratch using this diagram. So that way you need to understand this diagram. So the diagram is still showing see here, so that we can still make reference to it. Hope you get. So let's go to the next question now. So the next question here says that a body of mass 6 kg, I think it's showing on your screen, rests on an inclined plane. The normal reaction is R and the limiting frictional force is F, as shown in the diagram. Forget about the diagram, we'll get the diagram ourselves. If F is 30 Newton and G equals to 10 meters per second square, then the angle of inclination theta is dash. Now I thought we'll solve this question very fast. Along the inclined plane, we have, let's write out our formula quickly. We have okay, let's first write our parameters, so we just know what to do quickly. 6 kg rests on an inclined plane, so U equals to 0 is not necessarily since it's rest. The normal reaction is R and the acceleration. Okay, sorry, let's just use A equals to 0. U is also equal to 0. Okay, the normal reaction is R and the normal reaction R and the limiting friction is F. Okay, if F, okay, they gave us F equals to 30 Newton. If F is 30 Newton and G equals to 10 meters per second square, the angle of inclination is this. We already know that we don't have R here now, so it means what formula are we going to be using? Very simple. Come back to our stuff. F equals to W sine theta. You should know that by now you can derive W anytime you need it. I don't need to even write out even though it's diagram or anything. You see, it's very simple. All you just have to now go now is 30 equals to, what is weight? 6 times 10 times sine theta. And I'm going to solve my get my theta rather. So I have 30 equals to 60 sine theta. From there I have sine theta equals to 30 divided by 60. From there I get 30 divided by 60 gives you 1 over 2. Sine theta equals to 1 over 2. Theta equals to the sine inverse of 1 over 2. Sine inverse of 1 over 2 as a mathematics student should be in your head. So we're going to have 30 degrees because sine 30 gives you 0.5. That is half. So you see how simple it was. I didn't waste time for this question because we have wasted a lot of time in this video. So our correct answer is option B. Yeah. So I think from these examples you see that friction and inclined plane is very, very easy. All you need to know is the body sliding down the plane or is being pulled up the plane. Now let me say this before we call it a day. If a body is pulled up the plane, we are going to introduce a pulling force. If a body is pulled up the plane, we are going to introduce a pulling force. And from there, what happens next? If you introduce a pulling force, it means the body is moving up. It means your frictional force is going to come down. I hope this does not confuse you. So if the body is pulled up an inclined plane, okay, let's quickly just use this place. So if the body is pulled up an inclined plane, we're going to get so it's pulled up an inclined plane. So it means frictional force has to oppose the motion. Yeah. So frictional force is going to be acting downwards. Your W sine theta is also still here. It's always here. Please take note. Always. That's the resolution of weight along the plane. Yeah. That's the magnitude of the weight accelerating the body down the plane. Now, pulling force. Yeah, I said pulling force earlier. So, pulling force, we're using a force. We are pulling the body along the plane, up the plane. But this frictional force is going to now downwards. So it's not something that's confusing. What do you do now? Net force equals to the body is moving up the plane. So you have pulling, always know the direction of the body. Since the body is pulled up, it means it's P minus FR plus W sine theta. Why I put it in brackets, you know that both of them are going to carry a negative sign. Yeah, so we're going to do P minus FR minus W sine theta, and you have gotten your answer. So we're going to be doing inclined plane properly. I'll be showing you different scenarios on inclined plane. So what I want you to do is to go back to that previous video and watch the beginning of friction. Yeah, friction on an horizontal plane, because I said some important points there that we're going to be continuing on. But I'm going to define inclined plane from beginning. There are different scenarios of inclined plane and all that. But before then, let's take this question on friction. In case you see it in your exam, it does not follow the pattern I taught. So it's on kinetic friction coming to rest. That's a body that is coming to rest. So a body that is moving and comes to rest. It's going to take a different format entirely. Let me just quickly say this, because there are so many questions now. I saw so many questions in Jamb questions, like so many questions on this particular stuff, and many textbooks fail it. In this scenario, frictional force is not net force is not frictional force minus pulling force, or pulling force minus frictional force. No, it's not correct. It's a different scenario. Let me quickly just show you guys. So let's use this question. It says, I think it's showing on your screen. There's a body of mass 25 kg moving at 3 meters per second. Let me quickly write it out. Body of mass 25 kg. I hope you have gotten your notes already. Moving at speed 3 meters per second on a rough horizontal floor is brought to rest after sliding. So it's brought to rest, it means v equals to 0. So this is initial velocity, yeah, because it's brought to rest. When a body is brought to rest, final velocity is 0. You get it? Now, through a distance of 2.5 meters, through a distance of 2.5 meters, calculate the coefficient of sliding friction. Yeah, sliding friction is also known as kinetic friction. Now, when a body is coming to rest, the net force is not pulling force minus frictional force. Please take note. Net force equals to frictional force. Just have this at the back of your mind. This should separate you from other Jamb bites. Net force equals to frictional force. Please take note. When a body is moving and comes to rest, that's for kinetic friction or dynamic friction. Net force equals to frictional force. Now, let's solve this question. I know that net force equals to MA also. You get it? Don't forget. Now, let's quickly solve the question. We have that mass equals to this one. What is we look for? Coefficient of friction. And when you know that coefficient of friction equals to mu times normal reaction. Well, you know this formula, right? Alright, now, so from here, we already said that frictional force equals to net force, which is MA. So we can write MA here. Okay, we have mass there, but we don't have acceleration. So we have MA equals to coefficient of friction times reaction. And also, please take note from, remember this question is horizontal surface. I taught in the previous video about horizontal surface. Yeah, that in a horizontal surface, when you have reaction force acting upward and weight acting downwards, they are equal. Reaction force equals to weight for horizontal surface, so not inclined plane. You get it? Because for inclined plane, you have R equals to W cos theta. So please take note of the differences. Now, this means that for this inclined plane, we're going to replace that place with W. Yeah, that is MA equals to coefficient of friction times weight, which is mg. Now remember that acceleration was not given. So how do we look for acceleration now? How do we look for acceleration here? So remember that from the equations of motion, to look for acceleration under friction, always use the equations of motion. So we have different equations of motion. You already know them. V equals to U plus AT, S equals to UT plus or minus half AT squared, S equals to the U plus VT over 2, then V squared equals to U squared plus or minus 2AS. Now, when you know these equations of motion, so which one am I going to be using now to look for acceleration? We don't know time, so cancel out. We don't know time, simple. We don't know time, so it means I'm going to be using this guy to look for acceleration. Now, is it positive or negative? Remember the question said coming to rest. When a body is coming to rest, acceleration is negative. So this equation is going to be negative. But when the body is moving from rest, accelerating is positive. But when it's going to rest, it's negative. So please take note of the difference. So we're going to be using v square equals to u square minus 2as. Now, what is v square? V square is 0. U is what? Initial velocity is 3 square. Then we have 2a. What is s here? We have 2.5 meters. Now from there we have 0 equals to 9 minus 2 times 5, we have 5a. Now if you bring 5 here, we're going to get 5a equals to 9. If you make a solid of formula, just get 9 over 5. So from here, the acceleration is what? 1.8 meter. I think it should be 1.8. Yeah, sorry, it's a meter. Meter per second square. Acceleration equals to 1.8. 9 divided by 5 is 1.8. Now let's quickly move to the next part. Now we have looked for acceleration. What is the next of? Coefficient of friction. And remember that from here we said that where's our formula we derived? Okay, we said ma equals to mu mg. Now if you make a set of formula, you're going to get a equals to, that's we're using this guy. Or no need, just know that from here net force equals to, now net force equals to frictional force. So we have this is the formula for friction normally. So friction equals to mu times normal reaction. Coefficient of friction times normal reaction. Since it's equal, so we're now bringing ma. So that's how we got this stuff. In case you have forgotten. So we have a equals to umg divided by mu. Sorry, divided by m. This m here. So we're going to get a equals to mu g. And you can just solve it out anyhow you like. But now from here we have what is mu? Make mu set of formula as the rate of friction. We're going to get mu equals to a over g. From there, what's a? A is 1.8. Then what is 10 g? N as given in the question. From there you have 1.8 divided by 10. That should give you 0.18, which is option B. So you see, the question is very simple. I just wanted to show you guys that it's a different concept when a body is undergoing static friction, because one of the questions is going to be static friction and all that. But when a body is coming to rest, please take note that net force is no longer pulling force. Remember that for static friction we have net force equals to pulling force minus frictional force. That's when you have pulling force. Just go and watch that video again. I cannot explain that again. Frictional force. So net force equals to pulling force minus frictional force. But now net force equals to pulling force. Please take note. So let's quickly run. Now before we start solving questions on friction and inclined plane, let me show you different concepts. So we have two scenarios of friction and inclined plane. The first one is when the body is moving down the plane. So let's call it moving down the plane. Please follow me. I'm going to be very fast because this video is going to be very long. Moving down the plane. So the first scenario is when the body is at rest. So the first one, body at rest. Body at rest. So when the body is at rest, remember from the diagram of inclined plane to watch the previous video. These are inclined plane look. If the body is at rest, please take note that proposed motion is downwards. Please watch that video. I'm going to tell you what's proposed motion. For an inclined plane, the body is assumed to be moving downwards. Why? Because naturally it's supposed to fall down, not go up. So if the body is at rest, proposed motion is downwards. So remember that the resolution of weight along the plane is W sin theta, and the resolution of weight down the plane is W cos theta. I've explained everything in the previous video, so please look for that video. Now W sin theta, W cos theta. Now the body is moving downwards. What does that tell you? That since the proposed motion is downwards, frictional force will act upwards. Frictional force will act upwards. What does it tell you? Net force equal to W sin theta minus frictional force. W sin theta minus frictional force. Now, since the body is at rest, it means net force is 0. I said this in a previous video that net force is 0 when the body is at rest for a scenario like static friction. So we have W sin theta minus Fr, which gives you Fr equals to W sin theta. So when a body is at rest on an inclined plane, this is what you use, W sin theta. Please take note of this derivation, and always just take note, just know this one, always reaction is W cos theta. Always reaction is W cos theta. Please take note, always. Why? Because reaction acts upward, then weight act, the relation of weight perpendicular to the plane is W cos theta, or you can say vertical, in the vertical direction is W cos theta, and horizontal direction is W sin theta. I explained this in the previous video. So this one is always constant for everything I was doing today. I'm going to show you different scenarios of a body on an inclined plane. So the second scenario is when, let's call this B now. The second scenario, this one is body at rest. I cannot be writing them out, so you have to just write it out as I say it. So just write it out. So what's the second scenario? The second scenario is a body is unstable. That the body is on the inclined plane but unstable. So let's draw the diagram. Let's see. Unstable. So the body is on this inclined plane but is unstable. Now I told you the proposed motion is downwards. When the body is unstable, it's surely going to move downwards. Because the body is unstable, it's coming downwards. Not the inclined plane, it's going to slide downwards. So unstable, the motion is downwards, which tells you that frictional force is going to be here. And we already have our W sin theta. So you get. So now in this scenario, what is net force? Net force, or you can write it as F net. Net force equal to W sin theta. Let me just write F net here. F net equal to W sin theta minus frictional force, because the body is moving downwards. Now this is not equal to 0 like this one. The body is at rest. When the body is at rest, net force is 0. Net force is not 0 under this condition. Why? Because the body is moving downwards. The body is moving, so it's not in one place. You get. So it's unstable, so it's moving downwards. So net force equals to W sin theta, and remember that net force equals to MA. So you can say MA equals to W sin theta minus FR. Let me even show you another simple thing. I didn't even plan to do this. So we have MA equals to W sin theta is what? W is mg. Yeah, to find weight. So minus FR, that's frictional force. Now we can look for acceleration here. Simply, instead of wasting your time in the example, just do it straight. So you can say mg sin theta minus FR divided by m. Now let me show you another simple derivation. Remember that we said, I think I said in the previous video, just go and watch that video. I said that Fr equals to mu r, that's probability of friction times reaction. So from there we also have mg cos theta or W cos theta, weight cos theta. Remember I said it somewhere. Okay, this is, I tell you it's constant. Perpendicular to the plane, we always have W cos theta, which is mg cos theta. Now if you replace this guy here, I'm going to get mu mg cos theta. If I want to replace this guy here, I'm going to get what? Where will I use now? Okay, I hope you can see it here. So I'm going to have mg sin theta minus mu mg cos theta divided by mass. Now we have mass in both of them, so it means we can bring out mass. I hope you can see what I'm doing. I just have to do it. I don't want to kill the board now. So mg sin theta minus mu okay, we can also bring out g also. So you have mg, you see, mu so you cancel your mg here, mu cos theta. So you see mg mu cos theta divided by m. So from there, if you simplify that, we're going to get something like A equals, because M will cancel out M, so you're going to get A equals to G sine theta minus mu cos theta. Very simple to simplify, to solve questions like this using this formula. You get? So let me just derive it, but it's only applicable when the body is sliding downward and just stable, and frictional force is acting upward, like to oppose the motion downwards. So this is when you can use it. I just tried to show you a simple scenario in case you look for acceleration. You get? But you can still do something like this, like find your net force from here, then still look for your acceleration using MA. Then our net force equals to MA. So if you look for your net force, you can still do net force equals to MA, make A this square. You get? So I just want to show you that you can use it. You can just learn this one to be fast. Use the Jamb exam writing. But I tell people still solve it well. If you have time, solve it well. Don't just assume. You get? So let's quickly move to the third scenario, because I have so many scenarios to examine today. Okay, so the third scenario is when a body is pulled by a force. So let's call this C. So we have a body pulled by a force. So when a body is pulled by a force, it's called pulling force. So I'm going to label it pulling force. The body is pulled by a force upward. So it means the motion is upward. Please take note, the motion of the body is upward. Now, where will frictional force act? Frictional force will act downward. If you watch that previous video, I said something that frictional force must not always be up. It depends on the scenario. Yeah. So this is why I'm breaking it down in this video. Now, W sin theta will always act in this direction, whether friction is here or not. So it always acts here. So, but the body is pulled up the plane. So it means P. What's the net force now? F net equals to pulling force minus open bracket. Always open bracket. So you have, if you add both of them here, you're going to get W sin theta plus frictional force. So you have W sin theta plus frictional force. This gives you, if you open the bracket, you have P minus W sin theta minus frictional force when the body is acting upwards. Please take note, pulling force minus both of them. So you put them in bracket, and when you open the bracket, minus times plus minus, minus times plus, invisible plus here, minus. So you have P and W sin theta. Remember that F net equals to MA. So you can always look for your acceleration from here. Hope you get. So please just know this basic stuff. Just know how to resolve it. When know that frictional force is opposing motion. So if they say there is pulling force, if they say there is no pulling force, please know also, if there is no pulling force in this scenario, it will not be possible, because a body must always slide downward. Yeah, you cannot just have the body you will run away. So you say maybe just you put the block here and start moving upward, nothing is pulling up. You maybe say the world is about to end, so you get. So nothing like that can ever happen. So what's the last scenario now? So the last scenario is let's call it Z now. When a body that is unstable is pulled upward, the body is unstable, is pulled upward to be stationary. So I want to make the body stationary. The body is moving downward and it's pulled upward to make it stationary. So the pulling force upward will be labeled P. So the body is moving downwards. This one is very, very critical. I know, even I think a textbook showed this. One will level textbook. Not to mention the name. So a body is pulled, like the body is moving downwards. The motion of the body is downwards. But a force is pulling it upward to make it stationary. So where is frictional force? I know some people now be like, since pulling force is here, frictional force will be here. Since pulling force is up. Know that all we have been doing ever since, frictional force is like in the opposite direction and all that. But that's very, very wrong. So frictional force always opposes motion. Now, let me tell you where frictional force is. Frictional force is acting upwards. Why is frictional force acting upwards? Frictional force is acting upwards because the initial motion. Now, I introduced to you a new methodology. The initial motion was downwards. We're only trying to make it stationary by pulling it upwards. So the initial, you cannot now change friction. Friction is an invisible force. You get? So it's not like, okay, this pulling force now come here, frictional force will now come down. The body was moving downwards. Frictional force has been here. Yeah, frictional force has been upward. Not that because I now put pulling force, pulling force now has come here, so frictional force will come down. Is it easy word? So frictional force is upward. Why? Because the initial motion of the body was downwards. So please take note. Now we have what we call our W sine theta, always in this direction. Always in this direction. Now what is the net force in this scenario? We have F net equal to, where is the body moving now? The body is moving upwards because we are pulling it upwards. So we're going to have P plus FR minus W sine theta. So from there, remember the statement said that the body becomes stable or is being pulled up to become stationary. Always take note of the terminology. You don't want to face simple question. So that means that net force is 0. So I'm going to get P plus FR minus W sine theta. Since my W sine theta is negative, I can bring it to this side and becomes W sine theta equals to P plus FR. So this is what I'm going to be using when a body is sliding downward as unstable, but is now pulled by a force to become stationary. Frictional force acts upward. Please take note of this distinction. Now the last scenario is when a body is pulled like downwards. The body is pulled downwards. So let's take for instance, I don't want to clean down to. I want to compare it with this guy. So let's say this is the diagram now, and the body is pulled downwards by a pulling force. The body is pulled downwards. Now this 5. Okay, I think we have done E. So this is E. So the body is pulled downwards by a pulling force. So in this scenario, where is friction? The body is pulled downwards, and now that proposed motion is downwards. So it means friction is here. And remember, we always have our W sine theta here. Hope you get it. So friction is acting opposite the motion, and the pulling force is pulling it downwards. So we're going to have P in this direction and frictional force in this direction. So what's the value for that guy now? We're going to get F net equal to the body is moving this direction. We have P plus W, if you are writing this thing down, W sine theta minus frictional force. So from there we have P plus W sine theta minus frictional force F net. So this is the magnitude of net force. The body is not stationary, so net force is not 0, unlike this guy. That's why I didn't clean it. I wanted to show you something. This guy, the body is pulling it to become stationary. But this guy, the body is pulling it downwards, so it's not stationary. This guy, the body is pulling it upwards, while frictional force is acting downwards. Yeah, taking note of the difference between these two guys, because it now looks confusing. This guy, the body is unstable, so it's pulled to become stable. But this guy, pulling force is just pulling it, and just pulling the block upwards. You get? So there are two different stuff. This guy is unstable, so I'm pulling it to become stable. But this guy, I'm just pulling it. Hope you get. So there are two different scenarios. Friction is going to act downwards here, while friction is going to act upwards here. And friction is going to act where's this guy? Friction is going to act upward here, because I'm pulling it downward, and we're going to get P plus W sine theta minus frictional force, and net force here is not equal to 0, please, because the body is moving. So I hope we are able to get different distinctions. Now let's solve questions under friction or inclined plane. Now the first question we have here is a Jamb 2002 question 10. It says a block of mass 50 kg slides down a plane inclined at an angle of 30 degrees to the horizontal. If the coefficient of friction is 0.4, calculate the frictional force between the two surfaces. Now let's draw the diagram for this guy. Okay, let's just write it. Mass equals to 50 kg. What's the next thing? The angle equals to 30 degrees. Then coefficient of friction mu is 0.4. Then G is 10 meters per second square. Now they say look for frictional force. So I'm looking for frictional force here now. And remember all our formulas. You see a body slides down a plane inclined at an angle. So let's draw the diagram. We're going to have, this is the plane. So a body slides down a plane inclined at an angle. So there's no pulling force mentioned here. So all we just have is W sine theta and frictional force, opposing motion, because the body is moving downwards. So from there, when in our formulas, frictional force, net force equal to W sine theta minus FR. Yeah, and the body says slides down inclined plane and all that. We cannot look for net force here because net force equals to mass times acceleration, and we don't know acceleration. You get it? So we don't know acceleration. Acceleration is not equal to G, please. It's not equal to G. It's not equal to G. I think I said it in the previous video also. So net force equal to W. So that one is cancelled out. So what's the next equation we can use? Remember that we can resolve vertical also, R and W. So let's bring that formula now. We have W cos theta, not W, please. I think I made the distinction earlier. So we have R equals to W cos theta. Another of our derivation. This is 1. This is 2. Then remember that FR equals to coefficient of friction times reaction. So we have FR equals to coefficient of friction W cos theta. So let's call this guy T. So you get it. So from here, what can we do now? We say look for frictional force, and we have mass, angle, mu, and this guy. So it means we're going to be using this guy. Yeah, simply don't waste your time with example. You get, I'm going to do frictional force equal to 0.4 times what's mass there? 50 times 10 times cos 30 degrees. So you point out on your calculator. Let's quickly do that. We're going to get 173.21 Newton. That's option B. So you get, so you see the way it's simple to solve this question. Now let's quickly go on to question 2. So the question here says the diagram above shows a wooden block just about to slide down an inclined plane. Whose inclination to the horizontal is theta. The coefficient of frictional force between the block and the plane is, although let me just tell you, when you see a question like this on coefficient of friction always equal tan theta. Yeah, always equal tan theta. But for those when you're writing WAEC or any A-level exam, let's quickly just do this. So when you say that the body is sliding down the plane, the proposed motion is downwards. And they told us that okay, about to slide down the plane. I remember that we have W cos theta along this plane. Then, W sine theta along this plane. We have W sine theta. Then we have frictional force, always opposing, because body is moving downwards, so frictional force is opposing it. So what do you get from there now? You say find the coefficient of friction. So remember we said that net force F net equals to W sine theta when it's about to slide down the plane minus frictional force. Now let me say you something. It said about to slide down the plane. That should remind you of something. Static friction. About to slide down the plane, the net force is 0. Static friction. I told you that the definition of static friction is the force that is required to oppose a body that is about to move. The maximum force required to oppose that static friction. The body is just about to move. So the body is not yet moving. So we have net force equal to 0, which equals to W sine theta minus frictional force. Bring frictional force to this side, we're going to get FR equals to W sine theta. And our other resolution, we already have that R equals to W, calculating it, W cos theta. So that was equation 2 there. Then also we know that they say you look for coefficient of friction. Coefficient of friction. Coefficient of friction equals to FR equals to coefficient of friction times normal reaction, which gives us coefficient of friction equal to frictional force over normal reaction. Now, what is frictional force? Frictional force here is W sin theta. W sin theta. The reaction is W cos theta. It's very simple stuff. If you cancel out, you're going to cancel out W, and you are left with sin theta over cos theta. In mathematics, trig ratios, trig identities, we have sin theta divided by cos theta gives you tan theta. I purposely give this question in case other solvings like the maximum range and all those stuff. You are going to see sometimes that you are going to be left with sin theta over cos theta. Sin theta over cos theta is tan theta. So you need to struggle in the hall and say, you now say maybe the angle now is 30 and you're left with maybe when you start solving everything. So there's a time to say find ratio between range and maximum height and all those stuff. So maybe I'm left with sin 30 cos 30, something like that. I'm like, what will I do now? It's going to give you tan theta. So you're going to get tan 30. That's the trig identity. So that's why I did this question. So the answer there now is option B. I already told you already that it's going to be tan theta. Okay, so just if you are in the exam moment, just the equation, don't waste your time. Put tan theta. Let's move to the next question. So the next question here says the coefficient of static friction between a 4 kg crate and a concrete surface is 0.25. Find the magnitude of the minimum force required to keep the crate stationary on the plane. So find the magnitude of the minimum force required to keep the crate stationary on a concrete base inclined at 45 degrees to the horizontal. So we have mass equal to 40 kg. We have coefficient of friction equal to 0.25. Then we have magnitude of the minimum force. So minimum force required to keep the crate stationary on an inclined plane. So we have to draw this diagram so it not confuse you. Because when they say minimum force, now people be like, what's minimum force again? So because minimum force can hardly mean anything in physics. Let me draw the diagram so we understand. They said the coefficient of static friction between the 4 kg crate and the concrete surface is blah 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 blah. Find the magnitude of minimum force needed to keep the crate stationary on the inclined plane. Remember I said this thing that when a body is unstable, so they say the body is unstable, abi? Yeah. So I want to make it make it stationary now. We're going to use a pulling force. We're going to pull the body to make it stationary. So this minimum force I'm talking about is the pulling force. Now we are going to pull it to make it stationary. That means that frictional force is acting here. Remember, upward. Because the initial motion of the body was downwards. Please take note. And remember, the minimum force is needed to keep the crate stationary on the inclined plane. And we now have W sin theta always in this direction. So what do you do from here? Remember that net force F net equal to pulling, not for pulling F net because it is 0. But let's figure it out. Since the body is moving upward, finally you're going to get P minus FR. P plus FR minus W sin theta. Yeah. You know why the frictional force is upward, right? You know now. I said this because initial motion was downwards. You get it? Although the body is now moving upwards, the stationary, but initial motion was downwards. The frictional force was here. Now equal to P minus FR. Sorry, P plus FR minus W sin theta. So you bring W sin theta, you're going to get W sin theta equal to P plus FR. Now, what they say you find in the question again? So you find the magnitude of the minimum force needed to keep the crate stationary on the concrete base. So, what is the magnitude of the pulling force now? We are going to do pulling force equal to W sin theta. If you bring frictional force to that side, you're going to get FR. But in this question, they didn't give us the value of frictional force. But we already know from our other equation that frictional force equal to mu W cos theta. We already know. So I'm going to replace this equation with mu w cos theta. So from here we're going to be getting what? P equal to, what is mg? Just write it out, mg sin theta minus mu mg cos theta. From there, let's input values now. We're going to get pulling force equal to 40 times 10. Let's put in brackets times. Always put your calculations in brackets so as to avoid confusion. What is the angle? 45 degree minus, for this guy we have, what is coefficient of friction? 0.25 times, what is mass? 40 times 10. Hope you are following. Cos 45 degree. Now if you multiply everything here, I always like to tell students to multiply everything in the bracket. That's why I put bracket. Multiply everything there, then minus it from what you get under. Right? So let me punch my calculator. I'm going to get 40 times 10 times sine 45 degree, which is 282.84. 282. P equal to 282.84. Sorry, the first thing here, not P. So the next second one is 0.25 times 40 times 10 times cos 45, which gives you 70.71. If you subtract both of them, you are going to get P equal to, quickly do that, 82.84 minus 70.71. What do we get there? We get 212 newtons. 212 newtons. So that's what in the option D. So you see how simple this question is. Just that's why I taught you guys those applications. So in case I didn't solve any question on any of this application, you already have the idea. Now I've already solved question on this one, so you can understand how it works. That is not just magic. Now let's solve another question. We're not solving any questions actually. Now this is a very problematic question. Very problematic. Now it says the body is released from rest at the top of the plane, inclined at 30 degrees. Let's just draw it straight. So we have the body is released from rest at the top of the plane, inclined at 30 degrees to the horizontal and 4 meter high. So 4 meter high. They are telling us all this information because this question is problematic. We have 4 meter high. So the height is 4 meters. This is the height of the plane. This is the height. This place is called the length of the plane. The length of the plane or distance of the plane. You can call it S or you can call it L, anyone you want to call it. So distance or length of the plane. Now it says a body is released from rest at the top of the plane, inclined at 30 degrees to the horizontal. The plane is inclined at 30 degrees to the horizontal. 30 degrees. 30 degrees to the horizontal. I don't put angle. So 30 degrees to the horizontal and 4 meter high. If the coefficient of friction between the body and the plane is coefficient of friction is 0.3. Calculate the time taking. So I'm looking for time taking now. From this kind of question, you know I don't usually use the equations of motion because there's no formula from friction that gives you time taking. So I'm going to usually use the equation of motion, and you know the different equation of motion. Since you have distance and time and height and all those stuff. So the equation of motion, you have b equals to u plus at. You cannot use that one. B square equals to u square plus 2a. You cannot use that one because of v. We're not giving velocity here. Neither do we have. I don't think we know acceleration here. Okay, you can look for acceleration. So that one is also variable. But we have time. Okay, we don't have time without so you look for time. So the only two equation of motion that have time is s equals to r. Just write them out. So this one is very fast. You will just put the equation of motion in your head. Just easy for you. So s equals to ut plus half at squared. Then s equals to u plus v over 2t. So these are the equations of motion that have distance and time. Now let's quickly now eliminate between both of them because we have to eliminate one. Now we're not giving initial velocity here. It just said it's released from rest. Okay, is released from rest at the top of the plane, inclined at 30 degrees to the horizontal and 4-meter high. So he told us that it's released from rest. So initial velocity is 0. So we know both of them here. We can look for acceleration, we know now, from net force. But we don't know final velocity. They didn't tell us final velocity. They just said it slides down the plane. We don't know the final velocity yet. So we only know initial velocity. We're going to cancel this guy out. Don't have time to start looking for final velocity. And easily look for acceleration. What we get? So S equals to UT plus R is what I'm using. So the first thing is to look for acceleration. Now let's resolve this guy. Here is the forces acting. They say a body is released from rest at the top of the plane. Release from rest means it's going downward. If you look at the last statement, they say calculate the time the body takes to reach the bottom of the plane. So it means the body is going downwards. That's why it says released from rest. So it means that since the body is going downwards, frictional force is acting upwards. And the resolution of weight downward, along the plane is W sine theta. So you get, so it means that our net force is what? Class net force is F net equal to, the body is moving downwards, so you have W sine theta minus frictional force. There's no pulling force in this question. You get, there's no pulling force. Now, we don't know, we're not giving frictional force in this question also. We're not giving frictional force, we're only giving coefficient of friction. Whenever you see coefficient of friction, just know that, okay, I'm going to now use that third equation that says R equals to W cos theta. You know, simple. Just replace it into that equation because FR equals to mu R. So from there, if we replace, you're going to get F net equal to W sine theta minus mu FR. Sorry, minus mu, by replacing R with W cos theta. Now, let me continue with this guy. Now, we have something. So we have NA. I hope you guys can see this green stuff anyway. That one is almost finished. So net force equals to NA equal to, remember I did this thing. I made acceleration with a formula. So let's quickly run it. Or although I've done it, I have not done it again. This video will be too long. So let me still run it. So we divide both sides by mass. So I'm going to bring out mg sine theta minus mu cos theta. If you skip that part, please go back. So I'm going to get A equal to, if you divide it by m, I'm going to get A equal to G. I don't think this is visible, but minus mu cos theta. What do we have now? Let's just input our value. So we have A equals, I don't think that guy is visible enough. So let's just use this black. So 10 times sine theta is what? What's theta? Theta is 30. So sine 30 minus, you can just see, you can just learn this thing at the back of your head. In case the body is this scenario, that's why I don't want you to just learn it. So you just say just learn it. But don't just learn it too. It has to be this scenario. As frictional force is acting upward, why these guys acting downward, you get. So what is mu now? We have mu equals to 0.3 times cos 30. So from there, if you have A equals to 10, sin theta is 0.5, cos theta is root 3 over 2. So if you do root 3 over 2 times root 3 over 2 times 0.3, what do you get? Times 0.3. I'm going to get 0.26. 0.26. So if you minus them, I'm going to get 10 times 0.5 minus 0.26. So I'm going to get 0.24. If you multiply this by 10, you're going to get 2.4. So your final answer is 2.4 meters per second square. That's okay, there was no option. So okay, that's not what we're looking for here. We're looking for time. So we have seen acceleration now. So we can put acceleration into this question. But now Do we know distance? No. We were given height and not distance. So how do we look for distance? How do we look for distance? Now this question, when you have a question like this, remember our so we can look for length of hairs. I think it can be length of the plane or distance of the distance the body moved down the plane. You can call it s or hair. So if I'm looking for distance, what we do, we just use SOHCAHTOA. Since we have an angle opposite, the angle is opposite 4 meters over hypotenuse. So I'm looking for this guy. I think I did this in the previous video, something like that. So opposite over hypotenuse. So not this. Opposite over hypotenuse. So we are going to get sine 30 equal to h over s. You know that h is 30 opposite over hypotenuse, so h over s. So you know that h is 4. So write out of 4 over s. Then if you make a over 1 equals multiply, you're going to get sine 30 times s equal to 4 times 1. Now divide both sides by sine 30 to make s stand alone. It's going to cancel out. You're going to get s equal to 4 over sine 30. Now what is sine 30? Sine 30 is 1 over 2. As a physics student, you know this even though they wake you up from sleep. So 4 divided by 1 over 2. Let me quickly do this thing. I've been trying to explain. Some places may not even get it. When you have 4 divided by 1 over 2, you can easily just change it to times so that you can, it will easy. You cannot divide it like this. So you have to change it to times. You're going to get 4 times. When you're changing to times, the bottom comes on, the denominator comes on top. That's the bottom. Then the 1 goes down the top. So that's how it is done. So like this now, you can now have 4 times 3 gives you 8 meters. That's how you do division. When you have division, you want to make it simpler. Just change it to multiplication sign, and you are good to go. So that's the way this question works. Okay, that's not what we're looking for. We're looking for the question is so long. What are we looking for? We're looking for time. So we know distance now. Let's quickly look for time. They told us that initial velocity is 0. Yeah, they say it's released from rest. So it means u is 0. Okay, I haven't worked it out before. U is 0. So it means you're going to, yeah, it's 0. So there's no need to bother about it. So you have s equal to, you can write it 0 plus, because 0 times 3 will give you 0. Then plus half 80 square. Half, okay, where should we use now? So half 80 square, then you're going to get s is what? 8 equal to half times, what is a? A is 2.4 times t square. Then from there, you have 8 equal to half of 2.4 is 1.2. Then you have t square. Then from there, you get your t square equal to 8 divided by 1 over 2 to make t square stand alone. From there, if you punch that, you're supposed to get 6.67. 6.67. Now t square equal to 6.67. You take the square root of t so that t can stand alone, of t square so that t can stand alone, because square root cancels square. So the square root of 6.67 is what? Square root of 6.67. That should be 2.58 seconds. So you see the way it's a long process and everything. But when you understand the concept, it will be easier for you to solve. I'm just trying to break it down so you can get it. So these are you solve questions on an inclined plane. There are 2 problematic questions that some students have been sending to me. So let me just solve them. It's on how to find acceleration. Okay, let me quickly solve it on an inclined plane. Alright, so let's quickly just trash the question. Use the 2 diagrams. So the first question says a mass of 2 kg on a surface, coefficient of friction equals to 1 over 2, is connected to a second mass of 4 kg over a frictionless pulley as shown in the diagram. If the acceleration due to gravity is 9.8, then the masses will accelerate at. There are 2 ways of solving this question, but let me first show you the hard way. Now, what do you do first? This is a smooth surface. Remember our resolution that when you have a body on a smooth surface, you're going to get pulling force, frictional force, then weight downwards, then reaction upwards. So remember that stuff. Now in this scenario, what do we do? Net force, you see, if you look for acceleration, net force along this horizontal surface is what? What is the pulling force in this question? They didn't give us. Pulling force minus frictional force. Now we don't know what is pulling force. This is going to lead us to a simultaneous equation, and we now cancel out pulling force. So we don't know what is pulling force, but we know what net force is, MA. We have MA equals to P minus frictional force. Frictional force is coefficient of friction times reaction. Then we can also get mg. Reaction force is equal to weight. So from there we can also get mg. So we can have ma equal to pulling force minus u mg. So make pulling force set of formula, I'm going to get ma plus u mg. So this is equation 1. So we want to resolve this guy. We're going to have something like let's say 4 kg downwards. Sorry, its weight is going to be acting downwards. Then between these two strings, there's a tension. And this tension, we can also call it the pulling force. Let's just let's align with the P. So I call it the pulling force acting on this guy upwards. So here now, the resolution for this guy, we have F net equal to, that's the net force acting on this body now, it's F net equal to, it's acting downward, so we have weight minus pulling force. Yeah, so from there now we have F net gives us mass times acceleration. Then we have weight mg minus pulling force. Now this is equation 2. We can simplify both of them because we know mass. Yes, we didn't even highlight it. This is mass 1. So we know mass 1, we know mass 2. So we can simplify it and let's get a better quadratic equation. So you can get P equal to mass 1 is what? 2a. If you don't know, you are looking for acceleration. Then we know coefficient of friction as 1/2. So we can write our 1/2 there times 2. Then we know G as 9.8. Or we should just leave the G. Now, from there, you are going to get P equal to 2a half times half. So you're going to be left with plus G. We can call this guy equation 3 now, because I've modified it. Now this guy, we know mass, second mass as 4. So I'm going to do 4a equal to 4g minus p. So we wanted it to form a quadratic equation. That's going to be equation 4. Or let's even simplify this guy further now and make it in this form. So if I want to modify this equation, I'm going to get p. Let me bring a to this other side. Let's bring 2a p minus g to make 2a sound able to look like that guy. So these are proper equation 3. Now let's simplify all of this stuff now. Let's simplify it doing our quadratic equation. It's not a difficult thing actually. I don't know why some people were complaining. So we have 4a equal to 4g minus p, then 2a equal to p. Okay, let's interchange it to get this format. So we're going to get p minus g is also minus g plus p. Yes, because there's an invisible plus here. We're going to get to follow that format. We're going to get minus g plus p. We want to cancel out p in this equation. We don't know p, we don't know the pulling force or tension. Now one thing to take in about simultaneous equation is that if we want to remove any of the terms, because we want to remove p now. Let's see, if we do minus p plus p, the same thing as minus p plus p. So it means I'm going to get 0. What to remove it? But if you have done, let me say minus p minus plus P does not give you 0. Please take note. Minus and minus gives you minus. So you're going to get minus P, which gives you minus 2P. So that's not 0. So we're going to be using plus. So 4A plus 2A gives you 6A. 4G minus G gives you 3G. Yeah, 4 plus minus. Minus and plus gives you minus. So you're going to get 4 minus G, which gives you 3G. Then you have 0. Then you are left with your A and G. So if you simplify, you're going to get A equal to 3 over 6G, which gives you A equal to 1 over 2G. Now, we know the value of G. I think we're giving the equation as 9.8. You're going to get half times 9.8, which gives you 4.9 meter per second squared. So that's the way we do it. So let's quickly just run the second one. Since we have gotten the concept of how this thing works, let's just run it. So we already know that net force, F net equal to pulling force minus frictional force. Yeah, so we already know that MA equal to pulling force. I want to solve it a simpler way now. Frictional force. That frictional force equals to UR, which is UMG. So then we can now say this is okay. Do we know the value of K? They will not give you any value there. So you can leave it like that. MA, let's just call it equation 1. Now for the second one, second body, we have F net equal to, remember that weight is pulling it downwards. So you have weight mg minus the tension force acting upward, so minus P. Then we have MA equal to mg minus P. Let it follow this format. So I'm going to say MA equal to P minus P plus mg. So it follow that format. Know that there's invisible plus here, so we bring it to that again, minus P plus mg. So that gives it equation 2. Now if we combine both equations, we're going to get what? Now before thinking of combining both equations, I say always read the question very well. It said something in this question. It said in the diagram above, the angular mass M2 is adjusted until M1 is on the verge of sliding. So the coefficient of static friction. So it means they told us that it's on the verge of sliding, which means that acceleration is 0. Remember for static friction, the acceleration is 0. Please take note. So it means acceleration is 0 in these guys. So it means we have, so now I must read the question. I wanted to solve the question very fast. So we have P equals to 0 equals to P minus UMG. I want to simplify this guy now. So I'm going to get P equals to coefficient of friction mg. Now the next thing is MA is also 0 here. So this is equation 3 now. Then MA is also 0 here. So we have 0 equals to minus P plus mg. If you make it like that, you're going to get P equals to mg. So you have your equation 4. Now since we have P equals to UMG and P equals to mg, it means you can equate both equations. No need to use simultaneous equation in this scenario because P equals to this guy, P equals to this guy. So it simply means that we have P equals to I purposely give this for example because this is some other questions on stuff like this. So it means that you have UMG equals to mg, and common sense will tell you that you can simply do to make coefficient of friction the subject formula, I'm going to get mg over mg. Now I'll be making an error since I started. I didn't imply the m1 and m2. Please always imply it. You know how we solved the previous question, we now okay, m1 is 2 kg, but this one they didn't give us any value, so we must indicate it. So let's go back to the question. So this guy was for m1, m1. We gave us equation 3. So this is m1. So this guy was m2. So we give us equation 4. So it means we have um1 over m2. Now if you make it so your formula, just get m2 over m1. If you cancel out, you're going to be left with u equals to m2 over M1. I think that's option C. Option C. You see, it's a very, very simple question, and please just avoid, because I've done questions like this a lot of times. That's why I knew that some people now be like, I'll just cancel MB, U equals to 0. Is there a question? Okay, there's no option like that. So please always indicate which mass you are using and all that. Just like that. Now I want to show you my own shortcut. I have a shortcut of solving questions like this. So let me just do the first one for you. You're going to do the rest, the second one by yourself as an assignment. Let me do the first one with my shortcut. I wanted to just show you how this thing works using the long method. In case you forget the shortcut and all that, you can just get it. Now my shortcut, please. The first one is A equal to M2 minus coefficient of friction M1 open and close bracket G divided by M2 plus M1. This is when you are looking for coefficient of friction, you get, or when you are giving coefficient of friction. But when you are giving angle instead, you use A equal to M2 minus M1 sine theta close bracket G. The G is for everybody, so you have M2 plus M1. The questions we solved just now, there is no angle. We can look for questions on angle in case you see. Okay, I think mostly 100 level physics. Now we say we're going to solve question 1 using this stuff. We say look for acceleration in the first question. Then in the second question you look for coefficient of friction using this formula going to work. So I think they give us acceleration. Okay, acceleration is 0, so it's not working for us. Make A 0 here, and you cross multiply and get your answer. So let's look for the first one. We're going to do the second one as assignment. So we have A equal to, what is first mass in the question? We have 4. So the second mass is 4. Please take note of the signs. M2 minus coefficient of friction is half. So you have half times, what is the first mass? We have 2. Then we have 10. Put everything in bracket again, 10 because for everything. Then we have M2 plus M1, we have 4 plus 2. So you have A equal to 4 minus half times half is 1. So you're going to get 1. Put everything in bracket, you have 10. Then divided by 6. So you're going to get 4 minus 3 is, so 4 minus 1 is 3 times 10 gives you 30 divided by 6. You're going to get 5 meter per second square. Okay, I used G as 10 instead of 9.8. In the question you gave me 9.8. So if you use it as 9.8, you're going to get 4.9. That's 3 times 9.8 divided by 6. This one cancels, I'm going to give you 1 over 2. So you're going to be left with 9 times 1 over 2, which gives you 4.9. So you see, it's a very, very simple thing. That's the shortcut method I use in solving this question. I don't want to show you the exact process. So in case you are hooked in the hall or you want to test your answer, if it's correct, so you can do it. Now, I want to solve another category of questions before we call it a day in this friction class. Now, this question is not actually too related to friction, but just for people that have been asking it. So, it's actually on the resolution of forces also. So, let's just do it. So, it says a man stands on a spring scale placed in a lift. The lift descends at a constant velocity. As a result, the scale reads a weight of. Now, whenever you see a question on lift, use this method. You're going to have upward forces and downward forces. So you have the man. Let's just draw him as this. So this is the person. Now we have he stands on a lift. As a result, the lift descends at a constant velocity. Descends at a constant descent. Now, for this kind of question, if the body is going upwards, you use net force equal to tension minus weight. So this thing, you can call it tension or reaction. So, but preferably you like calling it tension. You can call it reaction. It's not different. So tension minus weight, you get. Now, but if the body is going downwards, it gives you F net equal to weight minus tension. F net equal to weight minus tension. Please take note of the two instances Now, you see these two formulas. Let's now solve this question. It says a man stands on a spring scale placed in a lift. The lift descends at constant velocity. To descend at constant velocity means what? It means that acceleration is 0. Remember, constant velocity, a is 0. Please just know these simple things in physics. That's how you get questions. Now, okay, I didn't even say it. Well, okay, we know that net force should be MA now. Net force should be MA. Now, which one are we using? The question will say descends. So it means the body is going downwards. It means we're going to be using this guy to solve this particular question. So it means we're going to have MA equal to, what is it you look for? You look for the scale reads a weight of, the reading of the scale is the tension. The reading of the scale is the tension. Please take note. The reading of the scale is the tension. So, or reaction. That's the apparent weight. So do something like that in physics, apparent weight. So that's the reading of the scale. You can see it anywhere. I think there's a question, there's a topic also, I think up thrust. Is it up thrust? They were asking apparent weight and all that. So if you see those kind of things, know that is the second weight, not the original weight. So this is the original weight of the person, but the reading of the scale. You say the reading of the scale, like that's the apparent weight. We know that okay, this is the weight of the person. We can determine from the mass. But that's what is the reading of the scale when so and so happens. It means we're looking for tension, reaction, or apparent weight. What we get? So we're looking for T. So it means that we have mg, weight is mg minus T. Now, what do we do next? We make T so we're going to get T equals to mg minus ma. To bring T to this place. You bring T to this place, it's going to become positive, and if you take MA to this place, it will give you negative. I have to make sure the formula. I thought you guys have to show you the formula. Now, what do you do next? A equals to 0. So, no need to even waste your time. You're going to have T equals to mg minus m times 0, which gives you 0. M times 0 gives you. So, you're going to have T equals to mg. So, it means that tension equals to the weight. So, that mg is weight. The weight. The tension of the body or the apparent weight, or what's the question? Say the scale reads that the reading of the scale is the same as the weight of the man. There's no change. So it means the correct answer is option B. Option B. You see, very, very simple stuff. Just know that okay, when the body is going up, use tension minus weight. When it's going down, use weight minus tension, and you are good to go. I think there's a past question that failed this question. And there's another question like that. I can't remember the question now. Just look for questions on this guy. This is what you just need. Just know, okay, constant velocity means that acceleration is 0. Initial velocity, speed is 0. Just know, okay, when the body has 0 velocity, speed is constant. Know that acceleration is 0. From there, you are good to go. You have saved yourself mark. Somebody will be struggling, you ask, what will I now do? They didn't give me any value. But if acceleration is 0, it means acceleration is gone. And mg equals to weight of the body. That's weight. So you see, it's a very, very simple question and all that. Now, I've taught you a lot today. I know this video is so long and all that. It's just wanted to make you understand the topic in depth. So go and solve questions on friction. From what we have done so far, you see that calculation to friction is very, very simple. Even the dreaded friction and incline plane, it's very, very easy. Just know how to resolve the forces in the vertical and the horizontal. So that will be all for today's video. I know you have learned something actually, you have learned something new. Just let me know in the comment section what you have learned. And as I promised at the beginning of this video, I will be giving you an assignment at the end. So just watch to the end and tell me your answers in the comment section. I'll be in the comment section to check out every response. I'll be marking your answer and telling you if you are correct. And so just let me know your answer. Just type out your answer in the comment section and we are good to go. Lastly, you know this video is going to be beneficial to your friends taking Jamb, UTME, or level physics. Please share this video to everyone that needs to see it. And don't forget to like this video, subscribe to this channel, and turn on the notification bell. And in case you want to be a part of unusual science tutorial, Jamb classes, wire classes, NECO, UTME, and what have you, just send a message to the number shown on your screen, and you get more information about unusual science tutorial. Because I'm co-founder of Unusual Science Tutorial. This video is also sponsored by Unusual Science Tutorial. So don't forget our slogan as usual: keep reading till you become the book. I remain the one and only Dr. Jamb, and I will see you in the next video.